Hello, so our goal today is to find or determine the missing side of a right triangle using the Pythagorean Theorem. And today we're going to start out with just a few numbers. We'll do an example, we'll solve for a missing number, and then we'll throw in some expressions for the sides as well that contain a variable, and we'll have to solve for that variable. So, quick reminder, the Pythagorean Theorem is a relationship between the sides of a right triangle. And there's lots of cool proofs on this. And so for this particular triangle, we might call this hypotenuse C, this leg down here A, and this leg here B. And it doesn't matter what variables we use, but it's pretty traditional to use C as a hypotenuse, which is that side that's always opposite, this side here, is always opposite the 90-degree angle. And I should probably show that it's definitively 90 degrees with one of those symbols. Okay, so let's come up with an example. What if, in this particular case, C was 10, let's say B was 5, and we wanted to know what A is. And I guess the units don't matter. We could pretend it's centimeters, but I'm just making these numbers up as an example. So we don't know what A is, so A is going to stay our variable. But we do know that I've said B is 5, so we can plug that in, and C is 10. And when we go to solve these for the missing variable, it's important to square the numbers that you do know. So I'm going to go ahead and write 25 and 100. And from here, it's pretty obvious. We're going to subtract 25 from both sides. We're going to try and get that a squared by itself. And it looks like a squared is going to equal 75. So when we're here, we want to remember the principle that the square root of anything squared is just that thing. And so we're going to take the square root of both sides here. And so a must equal the square root of 75, which is going to be an irrational number, right? And we can simplify that square root if we'd like. I think it's a good habit to think if we can, to determine if we can. In this particular case, we've already got the value of a. Let's see if we can simplify that square root of 75 down. I like to find the prime factors of a number when I'm trying to simplify its square root. So I know that's 3 times 25, and I know 25 is 5 times 5. So this thing right here, the square root of 75, is equal to the square root of 3 times 5 squared, which is the same thing as 5 square roots of 3, because the square root of 5 squared is just 5. And so this is a quick reminder. That's why we can pull that out of the square root sign. So all this to say that if we know, oops, let me get this out of our way. If we know that C in this particular case is 10 and B is 5, then A must be 5 square roots of 3. 5 square roots of 3 long. And the square root of 3 we know is a little less than 2, a little more than 1.41. So 5 of whatever number that is seems about reasonable. It's a little bigger than the side B here in this case. Okay, let's try a few more examples or problems, but let's use expressions for the sides rather than just numbers. So in this particular case, we're being told in this right triangle that the hypotenuse is 15, side B is 3x, and side A is 5x. And so we want to solve for x, would be the goal in this particular case. So if we're solving for x, let me get a little bit more room here. We're going to go ahead and use the Pythagorean Theorem to do that. It'd be one way we could go about it. And we can plug them right in, because we know that a squared plus b squared equals c squared. So I'm going to take my sides, square them, and set that equal to 15 squared. A common issue, I think, that gets some students is they'll go like this. So this will be a common error, I think, that I've seen. And that is they have forgotten, whoever's doing this has forgotten that it's the entire side squared. So, for example, this side here, 5x, we want to plug that into a squared plus b squared equals c squared. But we have to plug in the whole side, and that means the entirety of 5x squared, not just the x part. So really, it would be beneficial to have little parentheses here, I think, showing that the whole side is squared. And that's significant because instead of 5x squared, we're going to get 25x squared. Instead of 3x squared, we're going to get 9x squared, because the whole thing times itself. For example, if we have 5x squared, that's, as you know, 5x times 5x, so that's 25x squared. All right, so we'll go ahead and do that. 25x squared plus 9x squared equals 225, I believe. I think that's what 15 squared is. And so we'll combine terms now. 25 plus 9 is 34, so we've got 34x squareds being equal to 225. And it might be nice of us in this particular case, or nice for us rather, to go ahead and divide by 34 first. I could take the square root of both sides now, but that might make my answer just not necessarily look as neat as I'd like. So we'll go ahead and divide by 34 first. And I'm pretty sure that 225 and 34, or excuse me, 225 is not divisible by 34 evenly. So we're going to kind of be left with a fraction here. And from here, we're going to go ahead and take the square root of the whole thing. So x is going to be equal to the square root of 225 over 34. And as you remember, the square root of something over something else, so a fraction, is equal to the square root of the numerator over the square root of the denominator. So I can split this up. And we already know what the square root of 225 is. That's going to be just 15. So 15 over the square root of 34. And then there's this thing that mathematicians like to do, rationalizing the denominator. It's funny because some people think it's pointless and others really think our students should know how to rationalize a denominator. I won't give you my personal opinion, but if you need to know how to rationalize a denominator, all that means is we don't want our denominator to be an irrational number, and we know the square root of 34 is. So you just multiply numerator and denominators. You probably learned at some point, and if not, this will be a quick review, by the square root of 34, because the square root of 34 times the square root of 34 is just 34, and now we've got 15 times the square root of 34 in the numerator. And some might validly argue that this form of the answer is actually kind of, in some ways more complex than this form of the answer. But anyways, that's one way we would solve a problem like this. So now we know that x is equal to this value of 15 times the square root of 34 divided by 34, which is an interesting value. We could approximate that. But just remember that this thing has to still be multiplied. If you're looking at a side length, our answer would still have to be multiplied by 5 for this and 3 for this. And we know whatever those things are going to be, it's going to be less than 15 because the hypotenuse is always along a side, right? And that's 15. Thanks for watching, and I hope you found this helpful.